Leather shoes are one of the oldest forms of footwear known to mankind, but in today's world, the process behind making them has become a remarkably advanced and highly coordinated industrial operation. What most people see on store shelves or in fashion catalogs is only the final chapter of a much longer journey. A journey that begins far from the retail world, on farms and processing facilities where cattle hides are collected, preserved, and transported to massive tanneries. It is here where biology meets chemistry and raw organic material is transformed into durable, flexible, and beautifully finished leather. Fresh, raw cowhides arrive at the tannery in refrigerated transport trucks to prevent decomposition. Workers unload each hide, identify the supplier, verify the batch, and categorize them based on size, thickness, and overall surface condition. Scars, insect bites, branding marks, and natural wrinkles all contribute to how valuable a hide will become. Higher-grade hides are often reserved for premium footwear, while lower-grade material may be used for rugged boots or work shoes. Before leather tanning can begin, the hides must first be cleaned. Biological residue, dirt, manure, and blood are washed off using giant rotating drum washers. Water jets and detergents penetrate deep into the fibers, preventing contamination during later chemical processing. Once thoroughly washed, the hides are sent through dehairing machines. These powerful mechanical units strip away hair fibers using metal blades and scrapers. Modern tanneries rely on automation to keep the process consistent, but in earlier centuries, dehairing was done manually with blades and chemical soaking. After dehairing, the hides are transferred into alkaline lime baths. The purpose of this stage is to loosen collagen structures and swell the fibers, making the material more workable. These lime solutions also prepare the hides for fleshing, where rotating metal rollers press against the underside of the hide to remove fat deposits, connective tissue, and excess membrane. This step is crucial because unwanted material would later interfere with chemical penetration, dye absorption, and finishing quality. Now the hides enter the most fundamental step of leather production, tanning. Without tanning, a hide would rot, stiffen, and decay like any other biological tissue. Tanning permanently alters the protein structure of the hide, converting it into a stable material that can last for decades. Today, most footwear leather is produced using chrome tanning. In this method, hides are loaded into large cylindrical drums with chromium salts. As the drums rotate, the chromium ions chemically bond with collagen fibers. The outcome is a material known in the industry as wet blue leather, named for its subtle bluish tint. Wet blue leather is resilient, flexible, and able to withstand bending, twisting, and moisture exposure far better than raw hide. Once removed from the tanning drums, the leather is squeezed between roller presses to remove excess water, then shaved down to achieve a uniform thickness. Leather thickness directly affects the feel and performance of the final shoe, so this step is performed with extreme precision. After shaving, the leather enters the drying phase. Drying may take place on overhead lines, vacuum dryers, or temperature-controlled rooms depending on the factory. Once dried, the hides move to the re-tanning and coloring department, where pigments and dyes are applied. Industrial spray robots apply color evenly across the surface, creating tones that range from natural earth colors to deep blacks and rich browns. Fashion brands may request special finishes, including matte, gloss, satin, or distressed grain effects. Embossing is another important process, especially for fashion footwear. Using heated metal plates, embossing machines stamp artificial grain patterns onto the leather surface. This allows the industry to replicate exotic textures at a fraction of the cost. After coloring and embossing, quality inspectors examine each hide under calibrated daylight bulbs. They check for consistency, grain uniformity, gloss level, and thickness. Approved leather is transported to the cutting hall for footwear assembly. In the cutting department, modern technology plays a major role. Computer-guided CNC machines analyze digital templates and cut thousands of pieces with remarkable accuracy. Even the slightest optimization can save massive amounts of material in large-scale production runs. For premium products, artisans still hand-cut pieces to select the cleanest sections of leather with the fewest defects. Each shoe consists of several components, including the vamp, tongue, quarters, heel counter, lining, and reinforcement panels. These components are sorted into sets to begin assembly. Now the pieces move to the stitching hall. Rows of industrial sewing machines operated by trained technicians bring the leather pieces together. Heavy-duty synthetic threads reinforce seams, while decorative stitches enhance visual appeal. Branding logos are embossed on tongues, ventilation holes are punched, and soft textile linings are inserted to increase comfort. In addition, foam padding is added in areas that come into contact with the ankle and top of the foot, helping reduce friction during long-term wear. Metal eyelets are pressed in for shoelaces, and the assembled component now becomes a completed upper. Parallel to this, another part of the factory focuses on sole manufacturing. The sole of a shoe is not simply one piece, it often contains multiple layers. The midsole provides cushioning and shock absorption, commonly produced from EVA foam. The outsole, made from rubber, polyurethane, or thermoplastic compounds, provides grip and resistant properties. Outsoles undergo a vulcanization process where heat and pressure chemically harden the material. Specialized tread patterns are molded into the soles to improve traction on different surfaces. When both upper and sole components are ready, they meet in the lasting and bonding department. Lasting involves placing the upper over a foot-shaped mold called a last. Mechanical arms pull the leather tightly around the last, defining the final silhouette of the footwear. Heat chambers lock the shape in place, while toe boxes and heel counters are positioned inside the upper to give structural strength. Once lasting is complete, the upper and sole are bonded together using industrial adhesives. Robotic applicators spread adhesive with consistent thickness, and hydraulic presses ensure a strong, uniform bond. After bonding, additional reinforcement stitching may be applied to the perimeter, especially for heavy-duty boots. The edges are sanded smooth, and the shoes receive polishing treatments that enhance surface shine. Some factories apply protective waxes or waterproofing coatings to extend durability. This final finishing phase determines how appealing the shoe will appear on retail shelves. Before packaging, every pair must undergo extensive quality control. Technicians inspect for alignment issues, sole bonding defects, color inconsistencies, and stitching errors. Shoes are flex tested to ensure they bend naturally with foot movement, and sizes are verified through calibrated fitting blocks. Approved pairs are laced, labeled, and placed into branded boxes, along with tissue paper, warranty cards, and sizing information. Boxes are stacked onto pallets, shrink-wrapped, scanned, and moved to the warehouse for distribution. From here, the supply chain takes over. Some footwear is distributed domestically via trucks, while others travel overseas in shipping containers. Global trade plays a major role in footwear availability, allowing shoes produced in one country to reach consumers across multiple continents. Once they arrive at retail stores, customers evaluate style, comfort, and durability, often unaware of the extensive journey each pair has taken. The majority of buyers never consider tanning, chemistry, cutting optimization, stitching mechanics, or outsole vulcanization, yet these processes define the shoe's ultimate performance. Even after purchase, the life cycle of a leather shoe continues. With proper care, leather footwear can last for years. Oils, waxes, and conditioners keep the leather supple, while resoling services can extend life even farther. This longevity is one reason leather shoes maintain relevance even in an age dominated by synthetic and disposable materials. Leather remains breathable, strong, and naturally conforming to the wearer's foot shape over time. From cattle farms to tanning drums, from chemical laboratories to stitching halls, from molding presses to retail displays, the creation of a leather shoe illustrates an extraordinary intersection of biology, chemistry, craftsmanship, and industrial engineering. It is an invisible story beneath every step we take, a system so efficient that we rarely stop to consider it. Yet millions of people rely on it every single day, whether for work, fashion, or personal comfort. If you enjoyed this video, make sure to leave a like and drop a comment down below. And don't forget to subscribe to the channel for more factory inside and industrial documentary content just like this.